Fold the shape. Halves must match. Symmetry is balance.
Look at Willow the Luna moth resting by the quiet moonlit mirror pond. The wise math Sheba is here, watching the water. The surface is so still it acts like a perfect mirror. Every detail of the moth above the waterline is duplicated exactly in the reflection. But what if we step away from the edge of the pond? How can we know for sure if a solid shape has matching halves hidden inside its own design? Guessing by eye isn't accurate enough. We need a strict physical test to prove that two halves are actually identical. That test is finding a line of symmetry. This diagram shows exactly how it works. If you fold the shape along a straight line and the two halves land right on top of each other, that fold is a line of symmetry. You have to fold it and prove it. Every line has to be tested to see if the halves truly meet. Tonight, the pond is our laboratory. We are going to test the shapes we find here for those matching folds. Let's test Willow's wings. We will draw a straight vertical line right down her body. Look at this representation. The vertical line lights up, the left wing folds onto the right, and every eye spot lands exactly on its match. But if we fold it horizontally, the top half misses the bottom half. They don't match. So Willow's wings pass the test exactly one time. That's one line of symmetry. A fold passes only if the match is exact. Her anatomy gives that single vertical match. Now, Willow finds a square stone resting in the shallows. Let's see how many matching folds we can find on a shape like this. Fold the square top to bottom, and the halves match. Reset and fold side to side. They match again. That's 2. Now the diagonals. A fold from corner to corner lands perfectly. The other diagonal matches just as well. That gives us 4 perfectly successful folds. A square's equal sides and equal corners create multiple ways to fold the shape onto itself. Next, Willow visits a trillium flower. Notice how it has an odd number of identical parts, exactly 3 petals. Run a fold line from the top petal's tip, straight through the center to the bottom notch. The halves fold up and match. We repeat this test starting from the lower left petal, and a third time from the lower right. All 3 of these folds pass the test. Equal repeating parts, like these 3 petals, tell you exactly where to look for matching fold lines. Here are our 3 test subjects in one diagram: the moth, the square, and the flower. 1, 4, and 3 lines of symmetry. The rule is always the same. Fold the figure, check that the 2 halves match exactly, and count the folds that work. Finding these lines proves that symmetry is a physical property you can test yourself. Willow flutters off across the still water, her reflection creating one long, perfect horizontal line of symmetry below her. The wise math Sheba has shown us what to look for, and leaves us to keep testing. Before you go, look at this geometric outline of an equilateral triangle. It has 3 equal sides. If you ran the test in your head, how many fold lines do you think it has? Keep looking for these matching halves in the world around you. Fold it and prove it.
Mirror halves match. A line can fold. Balance proves symmetry.